The overriding theme of Thrust 3 is to use nanostructures to enhance energy efficiency. So nanostructures are materials that are grown on the nanoscale, so 10 to the minus 9 meters. So they're very small, and these materials grown on that length scale have unique properties, and these unique properties lead them to have interesting applications. And so what Thrust 3 is exploring is the use of nanomaterials in the general ballpark of enhancing energy efficiency. Solid-state lighting has the potential to be 80% or 90% efficient in terms of converting electricity to photons. The way that we traditionally use lighting, incandescent bulbs are 5% efficient and fluorescent lights are 25% efficient. If the country could make a switch to solid-state lighting, we would save billions of dollars a year in electricity costs and at the same time reduce greenhouse gas emissions. So one of the nodes in Thrust 3 is between Vanderbilt University and the University of Tennessee Space Institute, and we're trying to understand why ultra-small cadmium selenide nanocrystals emit broad-spectrum white light. Thrust 3, by being able to make materials, can funnel those materials to Thrust 1 and Thrust 2 for trial applications. Two researchers, a faculty member and a graduate student in Thrust 3, are making graphene, which is a nanomaterial that consists of one single sheet of carbon atoms. And it's very likely that graphene is going to play an important role in being an electrode for future generation solar cells. So one collaboration that's underway right now between Thrust 3 and Thrust 1 is to see if we can use graphene in those bio-inspired solar cells. One of the investigators in Thrust 3, who's at Tennessee State University, is making nanoparticle catalyst for fuel cells, which is a Thrust 2 research activity.
Last summer I had one undergraduate student. He worked with me for about 12 weeks. We were working in the area of designing and making molecular precursors that can function to make nanocrystals of a desired material that would have energy applications.
It takes specialized facilities to fabricate materials on the nanoscale, and it takes specialized equipment to characterize materials on the nanoscale. And then the other capability that the VINS facilities have is to allow us to do device fabrication. So the VINS facilities play a central role in Thrust 3 in that they enable us to fabricate and characterize nanomaterials. Given that we have this infrastructure for characterization and fabrication, we'd sort of like to open our doors and use that as a resource for across the state for people who may have specialized needs for characterization and fabrication.